All right, so part one of today's notes is going to be a lesson, I believe, what's this, number 7. We're going to talk about how you can identify whether a function has horizontal or vertical asymptotes. All right, so we're up here. These are the notes section. We're going to go directly from the notes as I explained to you. And there's kind of two understandings of this. So if you visualize what a horizontal asymptote looks like, okay? A horizontal asymptote is going to come across this way in general, all right? And so to identify them, we're going to look at the end behavior of the right or the left. So if you would plug in positive infinity as your x value over here on the far right, when you plug that in, if it approaches, the limit approaches a given y value, so think about like here's your y-axis, this is just your asymptote. If it approaches a y value, then your limit is going to exist, which is going to indicate that you have a horizontal asymptote. We can do the same thing with negative infinity. If we plug in negative infinity and it approaches a given limit, it means that you have a horizontal asymptote. A vertical asymptote is kind of the opposite relationship. So over here, here's your vertical asymptote. You're going to actually put in an x value for the input, and the output is either going to be positive infinity or negative infinity, depending if the graph is rising or falling in the direction of the vertical asymptote. So let's review that real quickly again. Over here on the right, you're inputting infinity or negative infinity, and you're outputting a y value if the horizontal asymptote exists. The vertical asymptote means you're going to be inputting an x value from either the right or the left, and the output is going to be either a positive infinity or a negative infinity. All right? So if we move down here to example 1, we have our basic graph of 1 over x. Okay? So if you take a look here, we want to talk about the limit at infinity. Okay, so I'm going to go back up here for a second. I'm going to make this red. So if I'm talking about inputting infinity for my x value, which is along here, I'm going to be talking about infinity over here on the right. Okay. So if we look at this as this graph, and I'm traveling right along here for this problem that I'm doing right now, what does it look like the y value is approaching, even though it will never actually be that y value? What's this height of this graph here? What's the y value going to be? What's this y value right here? 0. Okay. If we come over here to the left, which would be negative infinity, so now I'm going to do this box here, I'm going to be looking at negative infinity, which is over here. What is that value approaching? The y value? It's also going to be 0. Okay. So these two existences at the far left and the far right indicate that we have a horizontal asymptote. Now, if we go back up here and we talk about vertical asymptotes, okay, notice as we approach 0, so now I'm inputting this 0. This is from the right, so I'm coming along in this direction for this problem here. Okay. So there's a plus sign right here, 0 from the right. What is my y value approaching? So what is this y value going toward? Positive infinity. And if we look over here and we look at to the left, which would be 0 to the left, going down, we would have negative infinity. Those two things, negative and positive infinity in opposite directions, prove the vertical asymptote exists. So here's my vertical asymptote in blue. Here is my red asymptote in red. What you are seeing is what we did graphically when we analyzed, but now we are doing kind of a little algebra test and writing it using the limit notation. Any questions on that? All right, so let's move to the bottom and do a couple examples here. All right, so the first example is y equals x. This is a line. y is equal to 1 over 1 x plus 0, in case you forgot. So now, as x approaches positive infinity, so here's the x-axis. So what we're talking about is what is the behavior over there to the far right? What would you tell me that the y value is approaching as x gets bigger and bigger and bigger and bigger? What is y approaching? Anybody? Is y singling out to a single value, or is it actually continuing to grow? So that's going to tell me that this is going to be positive infinity also for the limit. If I look at negative infinity for my x value, I'm talking about this part of the graph on the far left. It's going to continue to go down, 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 down. So what is my y value approaching, or is it continuing to go down? As I get x to be more and more negative numbers, y is becoming more and more negative, which is going to be negative infinity. Okay. Then we can look at x squared. X squared is simply a parabola. As we look at positive infinity, which means we're traveling along this part of the graph, what is y approaching? Thank you, positive infinity. And negative infinity would be traveling along this piece of the graph. What is y approaching now? Going up, 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 up. Y is approaching positive infinity as well. Okay. So just as a recap, as you're taking down your notes and putting all this together, notice that our input values now are infinities. We haven't really seen that before. We've always had concrete, solid numbers, not these concept numbers. So if I'm looking at x cubed and I'm looking at positive infinity, I'm on this part of the graph. I'm going to positive infinity. If I'm looking at negative infinity, which is over here, that's this part of the graph, which is going to be going down, down, down toward the ground. So that's going to be negative infinity. Then we have x to the fourth. X to the fourth looks like x squared, but it's actually just a little bit more rounded out at the bottom. So it kind of looks like this. It's not quite as steep, if you will. Okay, positive infinity is going to be going to the right over here. So I still have positive infinity. Negative infinity is also rising to the left, so it's going up, up, up toward the sky, which is again positive infinity. So we can just answer questions not related to asymptotes, just what is the behavior as the graph continues to get bigger and bigger and bigger to the right, or more negative to the left, negative infinity.